In the previous video, we looked at diagnostics for the MCMC sampling. Here, we'll go over the goodness of fit diagnostics more typical in non-Bayesian analyses, some of which need special handling in the Bayesian context. This mostly follows the process of what's described in Merge Expo 1, which covers methods for some example FOCE models. But the main difference is in the use of the NM join Bayes function in the bbr.bayes package. So here's the function page on the bbr.bayes documentation site. This is used to generate a number of values in diagnostic plots using the full Bayes posterior. Now, the reasons for using the full posterior for these rather than just taking the point estimates directly from the NONMEM output tables is discussed in this tutorial paper here. There's a number of packages we make use of here. In addition to bbr and bbr.bayes, we use yspec to handle our data specification, which, among other things, allows us to use consistent labels in all of our plots and tables. pmplots generates the bulk of our exploratory and diagnostic plots. MRG solve is used to simulate from our model to generate some of the specific quantities that we need using the full posterior distribution. And MRG misc is used to format, manipulate, and summarize data. Let's scroll down to loading our spec file here. So this file that we're reading in, pk.yml, is a file in YAML format containing the data specification for our analysis data set. We load it in using this yspec function, ysload, and this allows us to use this object that we've named spec here at various points in the diagnostics process. So you can see it includes the variable name, the type of variable, a short label, and so on. There's other details about this yspec object covered in the page, but I'm going to skip over these for this video. And let's get to the point where we're reading in the model. So we're using the read model function from bbr to load in the model details. And here we're working with what will be the final model in this example analysis. That's model 1100. So let's talk about the model data set. So that model object that we read in here is then used to let bbr.bayes know where to find the analysis data set and any NONMEM output so that we can join them together using a unique row identifier, which we typically call num. For any key model in your Bayesian model development, you'll want to use this function nm join Bayes to set up the data for diagnostics. And this involves simulations using the full posterior to generate EPRED, IPRED, NPDE, and EWRES. This will require an MRG solve model, as well as individual posterior samples in .iph files that are output by NONMEM when you use the Bayes fee store equals 1 option in the estimation record. Without either of these, that is, without Bayes fee store equals 1 or the .iph files, you'll need to use the quick method described below, but this is not recommended for any key models. Since these calculations can take a while, we recommend you take advantage of parallel processing where possible. nm join Bayes makes use of the future package under the hood, but only if you configure it using the future plan function first, as we do here. And here we use all of the available cores except one. And now we get to actually running those simulations and join them onto the data set using nm join Bayes. Okay, this is optional, but we're using the progressor package to give us a nice progress bar so that we can monitor these simulations, which may take a while to run. Now, I mentioned before that we have a quick method for joining table output to the analysis data set, and that's using the function nm join Bayes quick. This could be helpful for interim models where you may not want to invest disk space for large .iph files containing the individual posteriors, or if you'd rather avoid the potentially time-consuming simulation process that we just looked at. Again, this is not the recommended approach for any final models. This just combines the point estimates of EPRED, IPRED, NPDE, and EWRES from the NONMEM output of each chain by taking the medians. So the rest of this model diagnostics process, it follows closely to the one we use for FOCE models in Expo 1. So that would be this page here in Expo 1. And you'll see that the figures follow fairly closely to what's in Expo 1. So I won't cover most of this in the rest of this video. I did just want to point out one notable difference. Since our population and individual predictions are calculated from the full posterior, we can visualize that uncertainty in some of these plots if we wish. So for example, in this plot of observed versus population predicted concentrations, we include 95% credible intervals for each of the predicted values. To help streamline the diagnostics generation for multiple models, I recommend you also take a look at this page on parameterized reports that we use for generating these diagnostics. Here we've set up an R Markdown template for each set of diagnostics. So that is the goodness of fit diagnostics or the model diagnostics, as well as the MCMC diagnostics. And then we can rerun these easily and reproducibly across multiple similar models. In the next video, we'll cover the last remaining topics in this expo, so that is forest plots, VPCs, and parameter tables.